Hello folks, this is Nigel at Spiritual Awareness New Zealand. It is May the 17th, Friday night, 7:39 p.m. 2019. And so this video is going to be just, how do you say, ad-lib. I'm making it up as I go along. But I made some interesting observations over the last several hours that I wanted to go over, and it's real interesting stuff. So let's have a look at this. This is, most New Zealanders will be aware that there was a lot of wind. We certainly had it hit hard here. If it had gotten any worse, then we would have had some serious damage happening in our property and so forth. As it was, I saw very little damage. Some branches down the road further. Nothing much really. But this is Takapau Plains, Central Hawke's Bay. It's sort of bordering on the Tararua region, and the winds we were getting were astronomical, and they are known to be it's known to be a windy area, if you like. I think they were predicting 130 to 140 kilometers per hour. Now what we actually got, I don't know, but the gusts were real strong, and it would have been at least up there in wind speed on the surface level. It was much higher wind up higher, as this article mentions. Troublemaking jet stream eases, but more gales to hit southerners this weekend. And further backing that up, there is a dusting of snow on the ranges here. So yeah, when we got up this morning, it's very light, but it's there, and it's real cold tonight. Looked at the temperature gauge just outside the front door, and it was 4 degrees. That was about 45 minutes ago, I guess. So I haven't even checked again. Now, this got me looking on a wider perspective, if you like, planet-wide. And a couple of days ago, I was also looking at data on the Magnetosphere had a serious dent in it this last couple of days, and I don't know if I can find that right now. I can try. Let me see. Oh damn! I don't know whether I can. I won't bother trying. Yeah, but it had a big dent. It went really close. Now, when the magnetosphere gets disturbed, we see these kind of disturbances, and in fact, there was a 7.5 earthquake in Papua New Guinea. When was that? Thursday? Anyway. So, and we got this, and these winds that we got were similar to, we got this about a year ago, or sometime last year. I can't remember. I think it was in September or something. Somebody could maybe remember that, but there was real serious wind. And I was trying to find my posts on it and so forth. I couldn't find them, but basically that last year was a similar, was the same sort of thing, and it was a magnetosphere disturbance. And what happened as a result was the polar jet stream moved up into New Zealand, and that is what happened over the last couple of days here. Is the polar jet stream moved up into New Zealand. Now that is where I started getting curious, and I'm going, well, what's going on here? And I looked a bit further, and what I have to show you is very interesting stuff. I can, well, I think so. And so anyway, what this article was saying, sort of just going through it, and it's saying surface winds were nothing compared to the roaring winds measured above Invercargill at noon on Thursday. Met Services midday radio sonde balloon flight from Invercargill Airport recorded a mean wind speed of mean, all right, a mean wind speed of 256 km per hour at 10,000 metres. Wind gusts would have been even higher. So that's what they were getting at 10,000 metres. Well, I was looking on one of the other Earth Null, and I was measuring the wind speed at various heights. Man, I mean, even at surface level, it was just going really, really fast. Shocking, really. It was really really moving it. In fact, I can probably show you that. Yeah, well, I can. I can show you what's going on. Although now it's slowed right down, so I can't show you what it was like then. But I want to show you that. Now, have I finished here? Maybe not. So, what else is here? There was some stuff. The buckle in this week's polar jet stream had allowed several fronts and a large cool pool of air in the atmosphere to move over the South Island. Polar jet streams were a constant feature of the atmosphere south of New Zealand and above about 8,000 metres, but it was less common to have such an intense southwesterly jet stream moving up the South Island and bring extreme winds to such low levels. So that let me just have a look at this. Correct, 10,000 metres, 10,000 feet. Okay, cool. Okay, right. So there's the jet stream there at 10,000 metres. Right, you can see that coming through here. It's it was right over the South Island, and the winds around Central Hawke's Bay, which is just around here, were they were severe. So what these guys down the South Island, I mean, they must have really got hammered. So that's that article, and now I'm going to skip over to, if I can find it, here. Okay, cool. Now, let's have a look at this. Now, this is Earth Null, and what I've got sampling here, two things. I've got the air, the wind, which you can see these movements here, those white lines. That shows you the wind movement, right? And then I've got the temperature recorded here as well, and the temperature you can see is the colours: red, orange, blues, cold, and so forth, right? Okay, now I'm going to have fun showing you this because to me it's just really shocking stuff. And so New Zealand's around here. Here we go. Okay, now let's have a look at this. Okay, so at the moment, this is the Antarctica, but basically the polar jet stream is supposed to generally pretty much go around this way, and generally it's actually quite connected, right, as one big just stream that goes around and round. Now, as you can see, at the moment it's not. We've got some stuff coming down here getting pulled down, and warm air getting pulled down here, and it's all circulating around here, and it's still touching the bottom of the South Island, and then it's sort of broken up into these little bits, right? Now I've seen this when it's all been just connected, and I've seen it when it's been completely disconnected. But at the moment, it's sort of, well, it's kind of functioning. It's, got a general movement in that direction and so forth. So that's the wind, right? And the temperature, so at the moment, if we click on this, let's have a look. Like here, for example, we've got that's 66 kilometers per hour right at that spot, right? Here it's 61. Up there it's 41. This is at surface level, right? And we've got temperatures of right here. We've got 10 degrees. It's not too bad actually. See, it's actually colder up here. 3.6 degrees. Whoa. Yeah, I told you it's about 4, right? So yeah, I wasn't. This is right on that, Okay, 1. Wow. So we're getting real cold temperatures in the North Island, interestingly enough. And then actually, generally, oh, there we go, 0.4. And that's over, well, what does that look like? Well, we can bring that up closer. It's on the west coast, sort of around Harst area, 0.4 degrees. Okay. Now, let's go further south, because I want to get you a bit of an understanding of what's going on here, right? Now, minus 3.9 there, temperature. Down here, minus 19, right? Now, notice the color changes. So this is minus 1, this is minus 21, right? Now, we go into that red or purpley kind of zone, whatever, pinky or whatever you want to call it. Minus 40, right? And the real dark one, minus 55. Okay, note those temperatures, just how cold it is there, right? And you get some kind of idea that, yes, this is the Antarctica, right? Okay, we go down here, minus 52. Okay, so it's looking like a cold place. Okay, and we've got the winds going around like this, right? Now, let's move and have a look at the Arctic. Now, when the magnetosphere got disturbed last time, we had a similar thing. This polar stream got completely disrupted, and the polar stream, jet stream, was coming right up here. That's what happened a couple of days ago. It wasn't going like this. It was actually coming straight up here, right, and then coming around. But it was coming through New Zealand and then around. Okay, so let's move to the northern hemisphere and have a look what's going on over there. Right, now this is the North Pole, and there's two things to watch on this. Here we go. Okay, now the first one is the wind, right? And as you saw on the South Pole, the Antarctica, there was a jet stream that went around the South Pole. Now, do you see any difference here? No jet stream, right? So that's one difference. And the winds that you do see are just kind of going all over the place. There's some coming in this direction. There's some coming around here. And it's quite slow, right? It's a little bit swirling around here. Almost nothing down here. Oh, yeah, a little bit coming down this way. Probably can't even see it. It's very, very, not very strong. Okay. Now, the other thing is the temperature. Now, let's have a look at the temperature. Oh, I don't know, right at smack in the middle here, for example. Minus 10. Right? Now, if we go over here, it's a bit cooler over here. Minus 18. Minus 18. Minus 21. Okay. Do you see what I'm seeing here? This is the Arctic. And minus 21 is about the coldest we're getting. Most of it is like minus 10, minus 6. The kind of temperatures you get in a cold place, but not in the Arctic, This is very, very warm, right? and very little wind flow, no extreme. Now, I think it's kind of weird in itself, and keep in mind also that there's been a considerable shift in the poles, the magnetic north and south. Over the last few years, it's gotten very fast, and it's moving, I think, from Canada over to Russia. So, so we've got a shift of that, and over here you can see some real extremes of temperature. Actually, I'm probably looking at that at an awkward angle, aren't I? So India is getting some real, and China and so forth, getting some real strong heat going on there, and so on. Anyway, so that's another story. But so we've got disturbed polar jet stream on the South Pole, and almost nothing, almost no polar jet stream on the northern hemisphere at all. So there's something kind of very strange going on there. Now let's have a look at, for example, this is Arctic sea ice news and analysis, right? And this is 15th of May, how much actual ice is there, and it shows you. Actually, bugger all. April reached a new record Arctic low sea ice extent. Sea ice loss was rapid in the beginning of the month because of declines in the Sea of Okhotsk. The rate of ice loss slowed after early April, due in part to gains in extent in the Bering and Barents seas. However, daily ice extent remains at record low levels throughout the month. Arctic sea ice extent for April 2019 averaged 13.45 million square kilometres, 5.19 million square miles. This was 1.24 million square kilometres below the 1981 to 2010 long-term average extent. Below the previous low set in April 2016. So it's really warming up over there. Now, see if I can jump back over to this one. It was 84 degrees near the Arctic Ocean this weekend as carbon dioxide hit its highest level in human history. Now, I'm not going to go into, man's influence and carbon footprint and all that bullshit, because I don't happen to believe this has anything to do with that. Certainly, the cutting down of trees over the years have probably had something to do with it, because trees produce a lot of oxygen. However, don't think that's. I think that's more to do with it than anything that man has actually had to do with it. Plus, there's a hell of a lot of volcanoes going off at the moment, so that's not going to do anything good to the oxygen levels. But these are all changes that are going through. Now, I'm not going to point my finger at any one thing particularly, and certainly not at man, like carbon influences and pollution and all that. Weather wars, weather modification certainly has been. There's a lot of that going on at the moment. But there is also this solar minimum that is taking place up until the year 2024. And actually even past that, it's when it reaches its low. And during a solar minimum, you can see a lot more cosmic radiation entering Earth, because the solar minimum weakens the magnetosphere. Right? This is these are certainly theories that are being pushed along at the moment, and I have nothing to argue with that. You know, I don't think anyone knows the real answers. Otherwise, we would all just go, "Oh, well, that's it," you know. And but it's certainly open to discussion. I'm not pushing any particular thing, accepting that it's happening, and it's certainly there's a big difference between what's going on, as I say, in the South Pole and the North Pole. So that's really that's pretty much what I was kind of observing. Yeah, I don't know if there's anything else I need to say about it really, but let's have a look here. Yeah, you can see what's going on here, huh? Pretty interesting. So to be honest, I still think that being down here is a better position than the northern hemisphere, especially when America is all set to invade Iran and so forth. It's you know and we've got Fukushima that is still producing huge amounts of radiation affecting the greater Earth, if you like, and that certainly could do a lot of change to this global warming thing. You see, maybe there's a lot more to do with that Fukushima and the Chernobyl and so forth. The huge amounts of increase in radiation on the planet, because you know, that will push up the temperatures. Okay, that's all from me, I guess, for the moment. I will let you know if I sort of come up with anything else, and if you can get through my videos, you're doing well. Okay, have a good weekend, and over and out.